Hello everyone. In this video we will see about transmission elements and harmonic drives. So first, what is transmission elements? That is a motion transmission mechanism. Is a system that transfers power or motion from a source to a specific application. And so why do we need motion transmission mechanism? That is, we need these mechanisms because they allow us to change one type of motion into another, alter the direction of motion, adjust the speed of motion, deliver a strong force where needed. These are some of the transmission elements. That's gears. You can see different types of gears, that is spur gears, rack, bevel gears, screw gears, and also chain and sprocket, power screw, belts and pulley, shaft and coupling. So these are some of the transmission elements. Next, harmonic drive. We'll see harmonic drive working in detail. So this strain wave gear is a type of a gear system known by a brand name. Okay, by brand name it is known as strain wave gear. So it operates on the principle of using the elasticity of metal to transmit the motion. This gear type employs a flexible spline with outer teeth that are deformed by a rotating elliptical plug to mesh with the inner gear of an outer spline. Here you could see in blue, red and green color. So inner one is the green color that is moving elliptically, and second layer is the red in color has outer teeth, and the blue in color has the inner teeth. Okay, so we will see about this in detail. Next, so these are the three components of the harmonic drive as we have seen earlier in the picture. So outer layer is the circular spline, and next layer is the flexible spline. So outer layer, the circular spline, which has inner teeth, and the flex spline has the outer teeth, and the elliptical movement the gear has, it's a wave generator. You can see here in this picture. Next, we will see the components one by one. So the first one is the wave generator. The elliptical movement is a wave generator. So this is a driven element in a transmission system. It's a specialized slim ball bearing placed on an elliptical hub. Okay. So this element acts as a torque converter, and it is connected to the gear input, which in turn links to the motor shaft. Next is the flex plane. So this gear is strong and rigid, yet it can flex when needed. So its outer teeth effectively handle heavy loads. It can also adapt to different shapes when the wave generator is placed inside the flexible spline. And then third layer is the circular spline. So there's a sturdy ring with teeth inside it. So when everything is put together, it locks onto the flexible spline's teeth along the long side of the wave generator's oval shape. The circular spline has 2 extra teeth compared to the flexible spline and is securely attached to the gear housing. Okay. So next you could see here the video segment of the harmonic drive.
The highly precise and backlash-free gears are the central element of the harmonic drive principle used in our gearboxes and servo actuators. Harmonic drive component sets consist of only 3 precision components: wave generator, flex spline and circular spline. The wave generator is the driven element of the transmission. The ellipse-shaped form of the wave generator is fitted with a specially designed ball bearing. The flex spline is a high-strength, torsionally stiff yet flexible component with external teeth, which reliably transmits high loads. The circular spline is designed as a rigid ring with internal teeth. The circular spline has 2 teeth more than that of flex spline. By inserting the wave generator into the flex spline, the flex spline assumes the elliptical shape of the wave generator. The rotating wave generator causes the flex spline to radially deform. The assembled gear has two diametrically opposed tooth engagement areas around the major axis of the ellipse. The rotation of the wave generator causes the meshing of flex spline with the circular spline to move around circumference. Since the flex spline has two teeth less than the circular spline, rotating the wave generator leads to a relative movement between the flex spline and the circular spline. Harmonic drive gears and servo actuators are used wherever zero backlash, extraordinary precision and high reliability are required, in all areas where drive technology is required.
The next is about the reduction ratio. The reduction ratio is given as flux spline teeth minus circular spline teeth by the flex spline teeth. Okay. So suppose, for example, if you have 202 teeth on the circular spline and 200 on the flex spline, the reduction ratio is minus 0.01, which means the flex spline turns at 1 by 100 the speed of the wave generator and in the opposite direction. So you can adjust this ratio by either changing the diameter of the mechanism or by altering the size of the teeth while keeping the overall size and weight of the system the same. Okay. So next we'll see the advantages of using this. The system offers some important benefits. It has no slack or play, meaning it's precise and responsive. It's very compact and doesn't take up much space. It's highly accurate in positioning. It's lightweight and easy to handle. It's very resistant to twisting. It can achieve substantial gear reduction. It provides good detail and consistency in its movements. It's excellent at repeating tasks with added weight. It can handle high levels of torque. It features input and output shafts aligned with each other. Okay. So harmonic drives come with some drawbacks, that is non-linear stiffness. The level of rigidity doesn't change predictably, making it a bit challenging to work with. Okay. Next is damping. So they have built-in resistance to motion, which can sometimes complicate their operation. And the third is complex flex spline design. The part that fluxes and interacts with the teeth has a rather intricate and detailed design, which can make the system more complex and potentially harder to maintain. Okay. So these are some of the pros and cons of harmonic drives. So this is harmonic drive used in a manipulator. You could see here in a manipulator, harmonic drive is used. Okay. So that is all about the transmission elements and harmonic drives. Thank you.